Thank you guys all for joining us on our rollouts here for Mastercam 2021. We're going to be going over Mill 2D and Mill 3D. For those of you who don't know me, my name is Brandon George. I'm one of the Mastercam instructors here at OptiPro. And I kind of specialize in the milling stuff, so I'll be able to go through all this new stuff going on in 2021. So I'm going to go ahead and get started. All right, so some of the stuff we're going to be covering. We're going to start with all the 2D enhancements in 2021, and then we're going to move on to our 3D after that. So in 2D, we're going to be going over dynamic mill corner pretreatment, a new option found in our dynamic milling. There's two all-new drill toolpaths, chamfer drilling and advanced drill. New options for lead in and lead out for a ramping method, and a couple new added options for spring passes. In 3D machining, we're going to be going over a new function called check tool reach, and it'll actually check your tool reach based on your holder and how much stick out you have. We'll be going over a new auto raster angle checkbox found in the high-speed raster toolpath. Advancements in our leads and links in between our toolpath slices. And then the last thing we'll be going over is new blend toolpath updates. So in 2021, they came out with a bunch of new updates for the blend toolpath. Well, in 2020, they came out with them, and in 2021, there's even more enhancements. So throughout my presentation here, I'm going to be jumping back and forth between PowerPoint and Mastercam, because the way I like going about this is just opening up a Mastercam file and show you guys exactly what's going on. So the first thing we're going to go over is the new dynamic milling corner pretreatment. So within our dynamic milling toolpath, there's now an extra cut parameter called corner pretreatment. And essentially what this is for is we can tell our tool to round our corners off before fully engaging in its first cut. Now, why people might use this is, say, our raw stock wasn't cut perfectly. It's not very square. We're concerned about the corners. Maybe there's really hard material and we want to cut the corners first. Well, this is exactly what this toolpath will do now. So I'm going to hop into Mastercam. Now let's take a look at what I'm talking about. So right here, we have just a polygon shape. I just drew a simple polygon because it's got a bunch of corners on it, so it's easy to show this toolpath. And right now, we're just looking at a standard dynamic milling toolpath. So right now, our tool just fully engages at the step over that we tell it to. So as we can see, it's fully engaged when it hits that corner there. Now, if there's extra stock on this corner for whatever reason, that might be a problem. We might actually break that tool there. So what we have now is inside 2021, this corner pretreatment. And what this does is basically it finds all the corners. We can change our step over. We can change what radius we want. We can change our feed rate on the corners, our spindle speed. And essentially all it's going to do is it's going to cut our corners first. And then it does that engagement right there. So now the corners are nice and round before we start to do our full engagement of our, 25%, I think in this case, step over. There's a lot of options in this as well. So let's take a look at this next one here. Here's one I did where maybe I'm using a certain tool. Maybe it's a really rough end mill and I don't care, if I break it or anything like that. I only want it to do the corners because I have a nice brand new tool after that I'm going to go ahead and do my dynamic milling on. So I can specify, okay, with this tool, I only want you to do the corners. And then I added a couple extra things here. My number of step downs. So I told it 3. So what it'll do is it'll take my top of stock and my depth, and it'll divide that in 3, and that's how it's going to figure out the step down. I also added 1 inch to my radius. So if we take a look at that, you'll see how much larger this radius is going to look now. So you see how now by the end of this toolpath, this part's starting to look basically just round? That's what we want before we engage that dynamic mill toolpath. So there is the same toolpath except with the whole, not just the corners, with everything on. And if you take a look, by the time we get to the center, it's basically just spiraling. Whereas the original toolpath, you can kind of see how it's still cornering. So it actually changes the whole style of the toolpath a little bit. One of the other things is we can basically increase the radius to whatever size we want, as long as radius to radius doesn't become impossible. What I mean by that is, say I put in a super large radius, like 3 inches. See how it just doesn't even do it? It won't, tell you can't do the toolpath, but it just won't do it. Whereas if I put in something like 2.3, it's still doing it. Now, if we take a look at how it looks after the corner pretreatment, it basically looks round. So with this toolpath, or with this corner pretreatment, you can pretty much make that number whatever you want it to be. It's a pretty cool new feature in dynamic milling. All right, so now we're going to get into the new chamfer drill toolpath. So this is an all new drilling toolpath that just specifies to chamfering holes. So with this toolpath, it's going to work with pretty much any tool that's got an angle on it. So chamfer mill, engrave, drill, spot drill, center drill, countersink, anything that's actually got an angle on it. And the angle does not have to be 45 degrees. It can be any angle that you want to define. And the best part about this toolpath is what it does is it'll be able to take holes that are different sizes, and based on what tool you select, it knows what depth to go for the exact width that you want to chamfer on the hole. So let's take a look at what that looks like in Mastercam. All right, so here's that part that I had in my presentation here. So we take a look, obviously it's a very simple part. We've got a 1/4 inch hole, 3/8 hole, 1/2 inch hole, and 5/8 hole. So what I want to do is I want to put a 20 thousandths chamfer on each one of these holes. So I'm using a 3/4 inch chamfer mill, and inside this toolpath, all we're going to do is we're going to select it exactly like we would any drilling operation. I just selected the solid feature of each one of these 4 holes. And in my cut parameters, I'm just defining a width. So our options here are defining width or depth. Obviously, we can put a dwell on for the bottom of the hole. And our linking parameters are pretty much nothing, right? Because it's all controlled by where that hole is. Obviously, you control your clearance and your retract. But Mastercam is going to figure out that calculation it needs for the actual depth of the tool. And just like any of the other drilling toolpaths, this is going to be a 3, 4, and 5-axis toolpath, depending on your package. So if you take a look at this toolpath, my 3/4 inch tool knows exactly which depth to go in order to put that 20 thousandths chamfer on. So it's pretty neat. And if we take a look at the stock model, we can see that 20 thousandths chamfer on there. Couple other things with this toolpath. If you define a depth or a width that the tool cannot physically do, it just omits whatever it can't do. So in this case, I chose all 4 holes again, and I just gave it some large depth that I knew the 750 tool couldn't do in the 625 hole. And all it does is it just completely omits this 750 hole. It doesn't tell you, oh, this is impossible, you can't do it. It just does exactly what it can do, which is really cool because if you think about having a massive part, we can kind of just window select everything and tell it, okay, what can I do with this single tool? And Mastercam will figure out what it can do and just omit what it can't do. Now, my other favorite part about this toolpath is that it can also do multiple depths on different levels. So let's take a look at something that's a little more complicated here. So I have, not only do I have different Z depths for my holes, I also have different size chamfers. So I think on this boss here, I've got 30 thou chamfers. On this floor here, I think that's a 50. And I think in here is a 40. So what's really cool is once the chamfer is actually drawn on in Mastercam or SolidWorks, whatever you guys are using to draw with, when I go to select my parts, all I'm doing is selecting the holes, just like we did before. You know, I'm selecting the diameter I'm cutting, and then all I have to do is tell it a width of 0. So a width of 0, and Mastercam knows there's a chamfer on there, and it'll actually figure out exactly what depth it needs to go. So again, linking parameters, all I do is set my clearance to make sure I'm above this boss. I could probably retract and incremental, that way I don't have the big, feed down. And now Mastercam can figure out exactly what depth it needs to go there for each one of these holes. So I think this is going to be a very widely used toolpath. People have been asking for, an intelligent chamfering toolpath. In 2021, we finally have something like that. All right, next thing I'm going to go over is advanced drill. So the advanced drill toolpath is essentially replacing custom can cycles inside your post processor. So this is going to replace anything from gun drilling to reverse counter boring, reverse spot drilling, and stuff like that. So now we can actually, our cut parameters are going to longhand define everything that we're trying to do. And this will be a really cool toolpath for those of you who can get really customize what you're trying to do when you're drilling. So the first example I want to show you is, say we want to do a gun drill. Before, in Mastercam, if we were trying to do a gun drill, it would have to be a custom can cycle or a custom post edit in order to do it. And for those of you who don't necessarily know what a gun drill is, it's essentially drilling a very long hole with a drill, obviously that's 10 inches, 8 inches. And the problem is you can't really turn the spindle on for that drill until it's already engaged to the material. You don't want to turn the coolant on or anything like that. A lot of times it's piloted with like a jobber's drill. So inside this advanced drill, now we actually have the ability to define everything we want for the gun drill. So my tool to cut this, I think I'm using a 10-inch long, half-inch drill. And if we look at my cut parameters, and again, this is the same way I'm selecting my part geometry is just like any of the other drilling functions. Both the chamfer drill and the advanced drill are going to select geometry exactly the same. So if we take a look at our cut parameters, what we're doing here is anytime I want to add, these are called segments. So these segments control new lines of code for exactly what you want to do. So this first move, I want to go into my part minus a half-inch deep with a slow feed rate. with a really low RPM. So my tool's barely spinning because this is a 10-inch long drill. If I crank up, my RPM to what it's asking me to cut at, the drill might whip. If I turn my through spindle coolant on, the tool still might whip. So I have everything turned off until I get to a 1/2 inch deep, because I'm assuming I've already drilled this hole, a couple inches deep or something like that. Then after I get there, I'm going to tell the drill I want it to go to the depth of my part, which is 7.5 inches, at the defined feed rate, 20 inches a minute. Turn my RPM, crank that back up to 2000, and turn on my through spindle coolant, and also do a 1/2 second dwell. And these can all be maneuvered in the segment modification order. So maybe I want my through spindle coolant to come on after my RPM. Well, I can move these around, which is really neat. And then the last operation I want, just retract out. Retract's always going to be at a rapid, so we don't need to worry about the feed rate here. I'm going to turn my coolant and my RPM off. And again, because it's the same thing as the chamfer drill and everything like that, I can output in 3, 4, or 5 axes. And my linking parameters are going to look exactly like chamfer drill. So let's take a look at what's going on here. If I backplot this, I can actually watch in my details what we have going on. So I'm going to use S and B on the keyboard, S for step forward and B for step back, and we can see what's going on over here. So if I step this through, I'm rapiding the tool down to my safe point, 1/2 inch above the part. And then I'm moving into my part minus a 1/2 inch at our slower feed rate. And again, this is when my RPM is turned really low. And then I'm going to crank the RPM on, and we're going to feed in at 20 inches a minute at our depth. And our depth is also included with that tip comp. And the other thing I can show you real quick, because technically if we look at my tool here, I didn't define my tool with enough cutting flute to do this. I defined this tool with a shoulder here. Well, we also have the ability to control all of our pecking. So per segment, we can peck. So for this segment, the 7.5 inch deep, maybe I want to do a full peck. And I'm just going to leave it at the standard settings here just to show you guys. So now if we watch this, now we're doing a peck cycle. And that peck cycle, because it's underneath that original cut parameters of the 1/2 inch, my tool's never retracting all the way out, which we wouldn't want that, right? Because the second our tool came all the way out at 2000 RPM, it could whip around and have a hard time going back into the hole. So that's just adding a simple peck cycle to that one segment. Let's take a look at a couple more examples. What if we had a part like this that had an interrupted cut in it? So before, with the standard drill cycle, our only options would basically be select the hole and drill to the depth. And all of this, say we were moving at 2 inches a minute, all of this would be wasted time. So now in the advanced drill, we can define, when we're cutting versus when we want to rapid or feed very quickly. And then when we're cutting again. So in this case here, and what's cool with this is if I want to check which segment is which, I can just kind of highlight over here and it'll show me which one I'm working with. So this first segment, we're cutting at a depth of minus 1.4 at a feed rate of 5 inches, standard drill cycle. But then once it gets to the minus 1.4 depth, I'm basically turning it all the way up. My feed rate's at 150 inches a minute, down to right before our next segment here. Slowed down my RPM a little bit. Probably didn't need to do that. My tool's already in. I just want to show you guys how customizable this is. And then once we get to this depth of 3.65, now we're going to re-engage our cut. So now we're going to go back to, the depth of this part at our feed rate of 5 inches. And then we're just going to retract out. And again, I can turn pecking on per segment. So if I want to do a pecking here, and then obviously I don't want to peck for this 150 inches a minute, I could also turn the pecking on for the segment where we're cutting again. So there's where we stop from the cutting to the full rapid through, back to our pecking, all the way through, and then it rapids out. The last one I want to show you guys is how we can do a reverse counterbore now. And for those of you who don't really know what I'm talking about when I say reverse counterbore or reverse countersink, take a look at this tool right here on my PowerPoint. Essentially, the way this tool works is you're going to pilot a hole, probably a little bit more than the shank of this tool. And then when we stick the tool down through the hole, probably without an RPM on, then we're going to turn an RPM on. And once we turn that specified RPM on, this part of the tool is going to stick out. Once this part of the tool sticks out, now we can actually cut upwards using Z positive. Before, there wasn't really a way that we could do that in Mastercam. Well, now in this advanced drill, we can actually tell it we want to go to a depth first with no spindle speed. Then we're going to turn our spindle on, right? We're going to flip that tool out, and then we're going to feed upwards. So at first we went to a depth of minus 1.8. Now we're going to a depth that's positive. So we're actually going to be cutting upwards at 3 inches a minute. And then we're going to rapid back down, turn the spindle off, then rapid through again, turn the spindle back on, and cut upwards again, rapid out, turn the spindle off. You know, I got dwells in here too, right? The dwells are going to make sure when that spindle turns off, that tool's got enough time to retract back in. Once that tool retracts back in, I can just wrap it all the way out that pilot hole. So let's take a look at what that looks like in backplot. What I've done is I've just defined like a slot mill that's going to look like that tool after it's popped out. Right now, we don't really have a way in Mastercam to define these specialized tools. So I'm going to step forward here, and here's where my tool is going to go past that first step, turn my spindle on, and then we're going to cut upwards into that counterbore. Pull back out, turn the spindle off, rapid through, turn the spindle on, cut up again. Come back down, turn the spindle off, wrap it out. So this is a really neat toolpath. I'm interested. I'm really excited to see what you guys are going to be able to come up with. There's definitely a lot of things that can be had with this toolpath. All right, the next thing we're going to go over, this is just a quick one here, is we have a new option for our simple 2D toolpaths for lead in and lead out. And then also in multi-passes, we have a couple new options for spring passes. I'm not even really going to go over this because it's very simple. Basically, all we have is before, if you had multiple Z cuts, your spring pass would only take a cut at the final Z depth. Now we have the ability to tell spring passes to finish after all the contours, apply to all the finish passes, just a couple extra options inside a spring pass. What I do want to show you guys is the lead in and out. All right, so what we have now is the ability inside lead in, lead out. Now there's a drop-down menu, and we have profile ramp. So profile ramp is super easy. All it is you give it a ramp angle, so in this case 10 degrees. And this ramp angle is going to be defined by where our top of stock is and where our depth is. So it'll do 10 degrees in between these two numbers here. So if we take a look at this toolpath, there's my lead in and lead out, where it's coming in at that 10-degree angle. And that'll go all the way around the part and come out at that 10-degree angle as well. So this is a big one for those of you who cut, you know, plastic or wood or a lot of those softer materials where you're just going to want to ramp right into it instead of coming in from the side and fully engaging the tool. And this is also going to go in line with multipass. So if I turn on multipass, you'll see every single time I do a multipass, it's going to do my lead in, lead out at that 10 degrees, but it's also going to respect the start and end only one time. So I only want it to ramp in at my entry and my exit. And what we'll see here is that nice one ramp in, and then the tool is going to stay all the way engaged for its 10 cuts and then ramp out. So again, it's a small improvement, but it's a thing that people have definitely been asking for a little while now. All right, another nice small improvement is in 2021, we can now roll in our face mills. So this is a thing that a lot of the face mill companies have been suggesting for quite some time now. Before, we only really had the ability to come in at a perpendicular angle to the cut. Well, now there's just this nice little checkbox to just check in face rolling. So I've got my part here. I just drew, you know, my bounding box to my material. And if I want to do a face mill, I'm just going to select my face. I've already got a 2-inch ISCAR tool already defined here. So before our cut parameters, let's just say one way, I'm cutting down to 0. And my depths, I'll just do everything incremental. So this is what it would look like before. Our face mill was always coming in right at that straight line. The only way to really change that would be to create your own geometry, which can be a pain. Well, now there's just this nice checkbox in our cut parameters that we could roll in with a radius. So I can just check this roll in box and I can give it a radius. Maybe I'll give it a 1 inch, which is half my diameter. And now what you'll see is we have this nice little radius that rolls it in. This is supposed to increase your insert life. It's supposed to be better for the machine and better for the tools. So again, nice little upgrade in 2021. All right, now we're going to get into the 3D machining. So one of the new features here that I personally really like when it comes to 3D machining is the ability to check our tools and what we can reach and what we can cut. So that's what this new check tool reach function will do. And I'm also going to go over radius curvature because it's an older part of Mastercam, but I feel like a lot of people don't use it or don't know about it. So I'm going to show you guys what that is too. This is a mold that we made here at OptiPro during this pandemic so that we could make safety glasses for the hospitals. And I really benefit, or I had a lot of benefit from the check tool reach here to figure out exactly what tools to buy, what tools I needed to reach, because once I bring this part up, you'll see that there's a lot of deep sections in here and there's a lot of small radii. So this is how I figured out which tools I needed to buy. Let me pop open that part. All right, so here's our ejector. So a couple things I noticed right off the bat. You know, there's some small radii in this corner here. This is a pretty deep pocket with some small radii in it. So I got to figure out how much tool reach do I need, how much neck length do I need in order to do this. Also in here, there's a small little section for the nose, trying to figure out which tools to buy that'll fit in there. So one of the first things I like to do is this radius curvature. So radius curvature is going to be found in the home page, and you're going to drop down check solid, and you'll see curvature. So what curvature does is it actually analyzes radii for us. It lets us know, based on what we want to analyze, what we can reach on this part. So say I wanted to figure out, okay, if I used a 6mm ball tool, how much of this can I cut? Well, all I have to do is type in the radius, so 3mm, and then I can hit analyze here. It'll tell me basically everything that a 6mm tool can cut. So some of the things we can obviously see here, it can't cut these radii in here. Those are smaller than 3mm. Again, a lot of this over here. It's telling me I can't really cut this runner. But what it's not telling me is, okay, what will it look like after I use the 6mm? Say I wanted to just surface the whole thing with 6mm tool. I kind of want to see what it's going to look like. Well, that's exactly what this new function will do. So check tool reach, which is found in Toolpaths all the way to the right-hand side, is going to shade my part based on what I can do. So I'm going to select my part. And now I've created a tool library here of what tools I had and what tools I thought I could use. So let's take a look at the 6mm. Rounded it out a little too much. So let's see exactly what this 6mm tool that's got 20mm of neck length can do. So I hit this preview button. It's going to generate for us. I'm going to turn my solid off so we don't have to look at it. And now this is actually showing me everything I can do plus what it'll look like at the end. So what we didn't see before, it just showed these red. But now it's actually showing us how much stock is going to be left there. So it's almost like doing a stock model, but well before having to generate any toolpaths. Now it's showing this entire nose area as red, because a 6mm tool just can't fit in there. It's impossible. Same thing with the runner. It's showing the whole runner is red now. So we can use this tool to see exactly what we can cut. So maybe let's see, okay, what can a 3mm ball do? All right, so there's a lot less red now. My 3mm ball can actually cut this runner. I'm seeing a lot less red in here, but I'm seeing a lot of red right here. I'm seeing a lot of red right here because this tool's not long enough. And I've defined the actual neck angle and everything on this. And I've actually defined my holder. So if I say use holder too, now let's see if that changes it at all. So my tool can reach based on my projection. I don't run into holder problems unless I try to go this deep, which obviously I wouldn't want to do with that tool. So based on my projection of the tool, I'm fine. But again, my neck length, I can only get so much of this radius. So what do I need to do to basically finish this nose piece? Well, I think I can use, let's try a 2mm. Again, I rounded it off a little too much, being too accurate there. So a 2mm will pretty much finish this whole thing. So this is how I figured out what I needed to use before having to do any toolpaths. Because for those of you who do surfacing, you understand how long it takes to generate these toolpaths and how much it can really stink when you go to do your stock model and you're like, oh man, I really thought that tool was going to be able to reach everything. So this is a great function now. And again, that's found check tool reach right here in Toolpaths. All right, auto raster angle. Again, it seems like such a small enhancement because it's really just a nice little bubble inside auto raster. but I love using the Raster Toolpath to do any sort of shallow surfacing. And I think you guys are going to see a huge improvement on your surface finishes now with this automatic, because when we take a look at this, you're going to be able to see how intelligent this automatic raster is. So here's a classic part I'm sure a lot of you guys have seen throughout our rollouts. It's just a simple die here. Now, what I've done is I've created just a raster toolpath, pretty much selected the whole part. I've told it, steep and shallow, I only want it to cut anywhere between 0 and 35 degrees. And in this case, before in Mastercam 2020 and anything before that, all we had for our machining angle was just custom with 0, or, whatever angle you wanted to find there. And what it would give us is just this 0 degree raster. So 0 degree in Mastercam is horizontal, 90 degrees is going to be vertical. And you'll see it's doing every single one of these surfaces exactly the same. Well, all I did was copy and paste this toolpath and just change this from custom to automatic. And now you'll see it's intelligent enough to figure out the best way to go about cutting each one of these surfaces. So the angle of these cuts is constantly changing. So Mastercam's determining the best way to cut this, which is really cool. It works out awesome. And it can get as complex as you want. So like I have a part here that's much more complex than this. And again, this is basically selecting the entire part and telling it, I only want you to machine the shallow surfaces and use that auto raster. And look at, it's constantly changing the angle it's cutting based on how well it can cut the surface, or the best way to go about cutting the surfaces. Seems like a small little checkbox, but it makes things a lot nicer. All right, advancements in leads and links inside our 3D toolpaths. This one, I'm not going to lie, is tough to explain. So when I'm talking about leads and links in between our toolpath, what I'm talking about is a transition between our toolpath slices. So each one of our stepovers. What we have now is the ability to take what we have in our leads, so how we're entering and exiting the part, we can now maneuver that into how we're transitioning in between our cuts. So the two new things you'll see is extension and apply transition. Apply transition basically means apply this to our in-between slices, and extensions, I'm going to show you guys what extension means. So I actually have this part open already because it took a little while for this one to open. So here's something pretty complex. And I'm just going to go through the steps of how we can really customize a toolpath to do exactly what we want. So all I did right here is an equal scallop. Selected my surfaces I wanted to cut. We can take a look at, my model geometry. I obviously use some avoidance. And I'm just doing a standard equal scallop, zigzagging out from center. Nothing fancy here. This is just the classic toolpath. Now, one of the first things I want to show you guys, a lot of people don't know this, our transitional movement here, the tangential ramp, a lot of times people see this angle here and they think it's only associated with the ramp angle. This angle is associated as well with the tangential ramp. So before in the first toolpath, I had that set to 10 degrees. Well, now I set this to 0 degrees, and you'll see that tangential ramp turned into a 0. So before, it was ramping 10 degrees around the part. Now it's at 0. Now, why would I want to do this? Well, because what I can do is now I can start to add transitions in between these slices. So when I say slices, each one of these cuts here, each one of these step overs is a new slice. So what I've done is I've told it apply these lead and link transitions between these slices. So I have, my entry and exit of a 1/2 inch, and then I just have some vertical entry and exit. And what you can see that it's doing now is it's doing this loop in between each cut. So it's exiting off the part and back onto the part in a looping motion. So I was like, all right, that's a really cool toolpath. I like that. But what if I want to do more of a raster style rather than, the equal scallop where there's a lot of start and stops between our corners here? What if I want to actually control the direction of my cut? Well, in 2020, when they released the ability to do trim curves, for those of you who use this equal scallop toolpath, in 2020, they released trimmed offset, and we can tell it, I want you to trim to this curve. So with that option in 2020, plus our new option in 2021 of applying our transitions, now I can get this really, really cool toolpath that every time it pulls off the part, it's doing a sweet loop transition in between each one of the cuts. It's coming all the way off the part, looping around, and then re-engaging. So I'm not doing a hard start and stop right on the corner. I'm fully exiting the part, looping around, and coming back in. Now let's take a look at what the extension one means. So say I have this shallower piece of land here that I want to do a raster on. Well, before, I think I have my apply transitions on still, but what's happening is our tool stops right at the section of this surface. Now, a lot of times people want to extend this surface so that the tool comes all the way off, then re-engages. Well, the only way to really do that in the past was you would have to create a surface from the solid and then extend the surface out. Now there's just a nice little box in here, the extension. So I'm in metric now. So I just did a 5mm extension. And now look, I'm extending all the way off that surface. So this will be a great way to make sure that the tool comes all the way off the surface before re-engaging. This will be another one that's a little bit more complex, kind of like the advanced drill, where you're definitely going to have to play around with it for a while to really understand how powerful it is. It took quite a bit of time to, really get it where I start to understand, oh, okay, this is what it means by apply transitions. It's in between my cuts, I'm applying my leads and my links. All right, and the last slide I have for you guys is the blend updates. So in 2020, they took the blend toolpath and they converted it to the new high-speed toolpaths rather than the older ones. And now with 2021, they've added a couple different new cutting methods, the ability to flip the step over without having to rechain it. And the big thing is the 3D projection as well as the tool contact point. So I'm going to show you what I'm talking about. So here's another good 3D part. Let's go over, I've just got some blend toolpaths on here. So this first one, I'll show you how the blend toolpath works for those of you who haven't used it. Basically what we do is we select what we want to cut. So I've selected these 4 surfaces here I want to cut. And then our toolpath control, we have to select what curves we want. So basically I'm telling it, I want you to cut those surfaces between that curve and the bottom curve. So some of the new functions in here, We have a couple new cut methods. From center to center are the two new ones. We can define a number of passes. So some people I could think of that would use this would say you had a certain angle where you've got a customized tool that's ground at that angle. This will be an awesome toolpath for that, because you can tell it, okay, I only want you to do 3 cuts up that blended surface. So if you take a look at that from center, all it's going to do is it's going to start at center, take 1 cut, and then 2 more cuts. Those are the 3 cuts that we defined. The other thing that's new, this is just the standard toolpath here. It's cutting from bottom to top. Before, if I wanted to reverse that, say I wanted to cut top to bottom, we'd have to go in and rechain everything. We'd have to flip our chains. Well, now there's just a nice little checkbox. Right now I actually had it flipped, but if I want to reflip it, all I gotta do is turn it off, regenerate it. And now my chain should start from top to bottom. For those of you who use Blend, you'll definitely appreciate that. All right, let's take a look at a steep surface. Because steep surfaces are Blend's worst enemy. Blend always hated steep surfaces because, say, in this case, I'm blending between these 2 curves here. Well, if we look down at this part, these 2 curves are almost right over top of each other. So the calculation for the blend toolpath really struggled with how to figure out, how do I blend slices in between curves that are almost on top of each other? Well, now in 2021, we have the ability to project in 3D. So there's this little drop down where we can choose to project within 2D or 3D. And 3D is going to be much nicer for steep surfaces. So the first thing we can see with this 3D toolpath is now it's actually got slices that look like the same step over. They actually look correct now. The only problem is, because we're still blending in between these cuts, my center of tool is still on that bottom chain. Well, that's an issue too, because if we take a look at this, it's obviously not cutting that whole surface. So the other huge improvement they've made to the blend toolpath is now in our toolpath control, we can contain it within the tool contact point. So now it's not only tool tip to the chain, it's tool contact point to the chain. And that's going to be different than this. It might be a little confusing, but it is different than this contain, because we're containing it within the curves. How we want that contact point to contain within the curves. So if we take a look at this toolpath now it's actually going to go all the way down to the bottom. So now that tool is actually going to finish that part. So some nice enhancements for the blend toolpath. Obviously, they got a good team working on Blend because they've been doing a lot of updates to it the past couple of years. And I think that's all I have for you guys, actually. So there's my contact information if you guys don't have it already.